of Module 4, Merge Sort, another sorting algorithm. Before we start this topic, I want to go over all the questions in Quiz 2. I will use 2 videos. The first one, still 5 questions. Second one, the next 5 questions. So each one approximately 10 minutes. All right, so let's start the first one, part 1 of Quiz 2 questions. The first one, given a computing problem, if we can use the brute force method to get the best solution, then we cannot treat this problem as a hard problem. Yes, we know the brute force algorithm is straightforward. There is no special technique. So usually we can treat as the simplest possible algorithm. So if you can use the simplest possible algorithm to solve a computing problem, can you say it is a hard one? Yeah, so, based on our intuition, so we cannot say it's a hard problem, right? So the hard problem, usually you use some advanced method, advanced technique, and also could be some very complicated procedure, some very smart design, that kind of thing. Ordinary people, not easy to find those advanced algorithms. So that kind of thing we can say, hard problem, right? Yeah, but definitely for this one, answer true. Yeah. By your intuition. That's it. Yeah. Do not rely on some definition, right? Yeah, we do not rely on definition. So completely based on our intuition, basic understanding. Yeah. The second question. We want to compare the efficiency between the selection sort and the bubble sort. Given an array without any inversion, increasing order, yeah, right? Without any inversion. So that means the array, it's an ordered array, already sorted. Yeah. In that situation, which one do you think performs better? First, when we compare these 2 algorithms, we know both has this property. Okay, big theta of n squared, but that's true for worst case, best case, average case. Both, right? So if you look at this, both the same. But if we really want to compare which one is slightly better, right? Even they are they have the same growth function. Sometimes we may like to compare which one is slightly better. That's possible, right? Yeah, slightly better. In that case, that situation, we need to look at the swap operation, number of swap operation. Swaps. The one with more swaps, worse. The one with fewer number of swaps, slightly better. So that's here I give you the general rule for the comparison. All right, so based on that, now we need to look at the number of swaps under the condition already sorted or already ordered. If already ordered, if you recall the procedure of these 2 methods, already ordered, then for both algorithm, no swaps. For Both. Why we need to do swap? Why we need to do any swap if there is no inversion? Right? Inversion, swap occurs only when an inversion is detected. How about that? That observation. A swap operation occurs only when an inversion is detected for these two algorithms. Only when. Yeah. So based on that observation, we can say these two essentially the same. Essentially the same. Right? Yeah. No swap for both. Essentially the same. All right? Yeah. Hope you understand this part. Yeah. So you can see for a question like this, I like you just to have a little deep understanding, not just, try to memorize some existing result. You need to have some basic analysis. You need to understand the details of both algorithms. Yeah. All right, so let's move to the next question. Number 3, given an array with these 4 elements, how many inversions can you find in this array? Check your understanding, the definition of inversion. What is inversion? Yeah, all right. So we count in this way. Okay. First, we count based on first element 4. Compare 4 and 2, 1 inversion, right? 4 and 3, another inversion. Yeah, accumulative. 4 and 1, another. So 4, we have 3 inversion. Okay. 2 and 3, no inversion, right? Yeah. Natural order. Yeah. Good order. Yeah. But 2 with 1 inversion. Okay. All right. 3 and 1 inversion. So another 1. Yeah. So total 5 plus 5. 5 inversion, the answer. Yeah. Very simple. Counting number of inversions. Yeah. All right. Number 4. Is the bubble sort an in-place algorithm? Check your understanding of this in-place algorithm concept. Yeah. Extra storage space is bounded by constant. This one. Extra means other than input output. Extra storage. Yeah, let me just write space. Okay. Bounded by this. All right. For bubble sort, let us look at the main operation, swap operation. Right? The bubble, yeah, every time you find a local inversion, you do a swap operation. Local inversion. 2 adjacent elements. That one, the swap operation, is in place. How about that? The swap operation just to use 1 extra storage space. So you copy data to 1 temporary variable. So then you copy, other 2 elements. Yeah. So that is in place. Each swap operation is in place. Then the whole algorithm, because 1 temporary location can be used repeatedly, right? So you do not need large number of extra storage space locations. Yeah. Only 1, you can do all the swaps. So that's why the whole algorithm is also in place. Yeah. Right? Yeah. All right. Next one. An efficient algorithm does not have to perform well for the relatively small problem size. This one, check your understanding on a critical point for asymptotic notation. Okay, yeah, asymptotic notation. When we talk about asymptotic notation, we said n greater than n0, right? There is n0. That n0 we can choose. We have freedom to choose where to start counting. Okay, yeah. So then, for relatively small size problem, the efficiency of the algorithms to be compared, not important. Not important. Another reason, overhead, right? Yeah. For that part, because some algorithm not very efficient due to overhead. What is the overhead? Preparation. You need to do a lot of preparation. Overhead part. Yeah. All right. Right. So true. Answer true. Yeah. So you can see that these questions are designed to check your basic understanding of certain concepts. Yeah. So you need to have a very good understanding. Yeah. All right. So let us stop the first video here.